All right, welcome and good morning to everybody. The first talk, or the first speaker here is a long-time Linux and open source consultant, and he's giving several talks at international conferences, written papers, and written a lot of articles. And one thing he's also known for is for his blog, Everything is a Freaking DNS Problem. I would like to welcome Kris Buytaert.
Good morning. Am I waking anybody up in the back? Okay, so you made a stupid choice. You're coming here for the talk with the most chaos in there. If you wanted to see fireworks, you should have been in the other room. Because James is actually putting on a fireworks show. You saw me update the slides of this, the title slide. It initially was a general talk about how to do application delivery. Then it became one about how we did this with Dashing, which is an open source monitoring tool, which is why Michael Friedrich wanted me to come and talk about it here, because it's about a monitoring tool. And then you also saw me update it from Dashing to Smashing because they rebranded. Who am I? Who doesn't know me? For who is this his first OSMC? Who see me 2 weeks ago in Prague? So yeah, my name is Kris Buytaert. I'm from Belgium. About 20 years ago, I started in IT. I've been doing open source since then in all kinds of different roles. Today my role is mostly helping organizations to deliver software. Somewhere about 8-9 years ago, we started running a conference about that. We called it DevOps Days, and since then everybody thinks that a DevOps engineer is a senior Linux expert who has been paid junior rates, and a lot of other things went wrong. But pretty much, I help people using open source. I'm part of a traveling geek circus, which includes Bernd, Toshan, Walter, a couple of other people who are here, who you see at OSDC, who you see at different other conferences. So, DevOps, because this talk is about delivering software. Who can explain me what DevOps is? Never, nobody ever. Even people who ran the DevOps track at another conference cannot explain me. Yeah, Jochen, I see you hiding. You won't fall into the trap. These guys did. Damon Edwards and John Willis, they ran a podcast, they still run it. It's called DevOps Cafe. And what they do is they interview people who are dealing with this topic. And they figured out it's typically about 4 key components, and that's how we end up having the CAMS keywords. It's about culture. Culture is how organizations or groups of people behave similarly, how they interact, how they work together, how they blame or don't blame each other, how their management structures are completely fucked up or brilliant. It's about automation, and that's mostly what this talk is about. When we talk about automation, it's build automation, test automation, infrastructure as code, pipeline as code, all these things, because we have computers to do the work for us. We talk about monitoring and metrics. That's what the rest of this conference is about. And we talk about sharing. We talk about open source. We talk about sharing responsibility. We talk about sharing experiences. And that's how we ended up with the CAMS keyword. And a lot of people think that if you want to do DevOps, that there's the ultimate way of doing DevOps is basically the backflip of what's on Jess Humble's book, which is the ultimate continuous delivery. The idea that you can take a piece of software, write the code, commit, and it's going to be in production minutes later. And you do that through automation, through collaboration. You have developers and operations people work together. And for a lot of people, that's what they really want to achieve when they do DevOps. So, back to this talk. Basically, this is an experience story of a customer I was at. And I'll be honest, I mean, the first time I submitted this talk was for OSMC last year. I didn't make it, and Michael said, yeah, you can come over and still do it. So it is about a year and a half old. But it was a team that had infrastructure as code in place. They had pipelines in place, manual pipelines back then, manually built pipelines. They had Puppet to spin up a Tomcat stack, GBOS stack in like 5 to 10 minutes. They could reproduce full development acceptance production. And they were pretty happy doing that. And they were slowly looking into adopting new technologies. And one of the topics we had there was the problem where we were building dashboards for the monitoring and the metrics, and we were trying to understand how do we do this and how do we actually automate that part also. So we were trying to build a pipeline for dashing. I'll come back to dashing later. But if we build a pipeline, and realize I'm kind of standing in front of the screen, what we should be doing is take a piece of source code, check it in, get some feedback, test. If it fails, we start over again, and we keep doing that until we actually have a release, until it actually is in production. Lots of environments, lots of organizations fail, make a mistake here, and they go further, and they don't really test anything. But that basically is the idea of a pipeline. If you look at a screenshot, this is a pipeline of our Puppet code ages ago, September 2012. Fuck, that's long ago. That was our Puppet pipeline back in those days. And people start building these things for all kinds of applications. And we do that because we want to be able to constantly be able to deliver software. The idea about delivering software is not that we do it 5 times a day, we do it 10 times a day, we keep doing it. No, it is that at any point in time, I want to have a piece of software where I know that if I need to do something now, if there's an upgrade, if there's something, if there is a security fix, I know that I can do it now. And I don't care if it's a Friday afternoon at 5, or a Sunday morning, or Wednesday midweek. Because it's going to be easy, it's going to be transparent, it's going to be trivial, and it's not going to be painful. So people will still say, don't deploy on a Friday. Yeah, I get that pain. I didn't want to deploy on a Friday, but it shouldn't be a problem. So this is basically a snippet from the release notes from Deployinator, and when I was giving a similar talk, but then mostly about how we do the same with infrastructure in Prague a month ago. Somebody from Etsy was actually in the room. They're still using this tool. Well, maybe it's a toy, because I don't see any other adoption for it. But for them, that pattern is also still out there. The fact that we can do it, the fact that we constantly have the power to release quality software, that's something they don't want to negotiate about. So what do we need? We need to have an artifact, something that we know that that artifact is something we can deploy, that it hasn't been changed, that it hasn't been modified, and we know that we can use that same part in development, in acceptance, in different environment, in this disaster recovery, anyhow. So we typically package. And I give a bunch of these things to give you a background on how we build the infrastructure to do this. So from an ops point of view, we want to package software because I don't want devs to log on a machine, modify files, and I won't be able to see if they modify them. I want to use the checksums. I want to make sure that the package is still correct. I sometimes need to deploy packages in all kinds of weird locations, behind a firewall, over a satellite link. And I know that packages are going to be something that I can deploy all over the place, that I can ship with a little overhead. It's also the moment when I start doing packaging, it's also when I sit down with the developer and say, hey, what do you want in a package? What do you need? What actually does your software depend on? Where are you going to store files? Are you going to write to log files? Do you need something on a disk? What do you need? It's where's your configuration? And then we have the discussion like the configuration really shouldn't be in a package. You need to externalize the configuration. So I have a config management system that can do this. We'll come back to the config later. So the application we were dealing with was, at that point, dashing. It's been rebranded to smashing now, but this is what a dashboard could look like. It's a tool that allows you to basically bundle together a lot of upstream tools. I mean, this one is an example of a bunch of Vikinga stacks, different ones. We figure out who's on call. We have a number of Jenkins builds that are successful. We have different Foreman instances, and we actually have metrics of applications in that. And you can build and do these things together. And we have different teams actually building different dashboards. And that was a challenge, because we wanted to have those deployed, and we didn't want the dashboard to break. And sometimes people actually logged onto the machine running the dashboards. They slightly modified some HTML or some tile somewhere, and dashboard was broken. It's not something you want. So yeah, for those who think dashing is dead, it's not actually. They forked, they rebranded. It's now much more active than before. So, but it's not the perfect tool. It's really awesome because you can have a lot of upstream people who have like, hey, I already built a widget for this, you can reuse this. And it's really easy to start. I mean, I'm not a Ruby hacker, but I can write scripts for dashing that actually work pretty fast. And there's the fun part about the event stream if you want to have debugging. Now, it's also really ugly. I mean, who likes deploying Ruby applications? I mean, we used to laugh with the Java community if you said Maven build downloads the internet. Yeah, Ruby does pretty much the same, only it's much more mess. And then there's the other thing with a lot of those upstream widgets. The default way that the dashing community says you have to install is basically you git clone a gist from GitHub. Like, that's like a snippet. How do you do release management on that? And it actually gets even worse. By any chance, who wrote the Akinga plugin for dashing? Is he in the room? Okay, it's fine that you're hiding because I don't know if he's in the room or she's in the room, but it's horrible. The config is inside the code. Like the first couple of lines is basically you need to talk to this Akinga instance or this Nigel's instance. So parameterizing that outside, it's horrible. We need it. If you have multiple instances, like this stack here, there's different customers, different environments. The initial attempt to do that was literally like run different copies of the script, rename it, before we started taking out the config. So it wasn't really, it was easy to do, but it wasn't really manageable. So we wanted to come to a point where we could just pin up a dashing stack, have a developer play with it, commit its changes to Git, and then promote it and move it to production. So how do we do this? Well, gem install dashing, and then gem pulls in the internet. And when you do it 2 days later, you get a different version with different dependencies. And when you do it a month later, it doesn't work because the Ruby version needs to be updated. And did I say I don't like Ruby? So reproducibility was really a problem. Specifically with developers taking random new versions from the internet and trying to get them to work. It was really fun. And that exactly is what we tried to fix with all the other deployments we did. Our typical stacks, like mostly CentOS, packages are being built with FPM. We build them in Jenkins. We upload them to Pulp. We have repositories. We download. I think I gave talks about how we use Pulp as repository management and stuff in previous conferences. And that's how we package software, how we ship it. Then the config is managed in Puppet. And depending on the environment, there's different variables. So I can configure which Akinga instances. And the services also. So this is a typical PCS pattern package service config. But building the package was pain. How do we build a package with all those Ruby dependencies in there? I mean, you could individually try to package all the Ruby gems and then have dependencies manage that, but that was really not going to work. There's tools that try to do that for you. But what we really wanted was like a pattern that would work for not only Ruby, but also for Python, for Node, for all the other things. And we needed to have a shroot with the right version in there. Python has virtualenv, Ruby has RBenv, and basically have a completely self-contained package that we could ship to any platform and say, hey, in this directory, this application is deployed with all of these dependencies. Back then it was Ruby 2.1 we needed, and we're like, well, what if we tried to build this in this new hype? I'll get back to Docker later, but it's like we've been using containers for ages. And what if we try to just use this container as a build environment where we spin up a container, build everything, package it, and then throw away the container? It would give us a couple of things. It would actually give us the experience, and it was 2.5 years ago, on how to build and how to manage containers. Well, Docker back in those days. So there was a plan. Let's do this. So we started building a couple of pipelines. One to basically build a clean package with dashing and just dashing. That was the initial plan. And then another one with all of our local code in there. So the idea was that we could deploy our dashboards and all the scripts we needed on top of the already existing clean dashing package. We later moved away from that. Now it's one package because we never actually had the isolation between the releases. So now it's one big package. And the goal was that ops folks and developers would not just log onto the dashing machine, modify some small templates and things in their config and break the dashboard while everybody was looking at it, but we actually had the same development, acceptance, production, staging environment as we had for all the other platforms. So we used Jenkins. And we figured out, let's make it more complex. Because the other problem we had with a lot of the stacks is that, well, who runs Jenkins? Who runs Jenkins for more than 10 jobs? For more than 100 jobs? For around 1,000 jobs? Who does that manually? We were. And all the developers were maintaining their own jobs. And they were clicking and cloning, and none of the jobs were in sync. And we, at that customer, actually, there was a bunch of Jenkins masters hidden under desks. And we needed to figure out a way to centralize those. We need to figure out a way to make that maintainable. So our stack was, we scratch everything. We start with the same pattern again, a Jenkins development box where everybody can play and create his jobs. And then we have the jobs being promoted to production Jenkins where only automated jobs can run. One central master, a bunch of slaves on demand, as much as we need. And we wanted to have it reproducible. So we also set forward the idea that you do not use the UI anymore to create jobs. I'll come back later on how we do that. So it was like, we're going to learn containers, we're going to do pipeline as code, we're going to fight with Ruby to solve this one little thingy, like we want to have a stable dashboard. So setting up the build environment. We need to have a container, step 0, which was the one that was reflecting what production was going to look like, which we could use to build the application. So whole stack is CentOS, recent CentOS version. We need to be able to pull in the dependencies that looked like the platform, and we need to be able to build. So how do we integrate that with Jenkins? Back then it was trivial, we figured. There's plugins for Docker in Jenkins, except none of them worked. Except all of them kind of expected you to have Jenkins running as root, stuff like that, like crazy shit. Crazy shit only developers come up with, which have no production experience. Or, well, this was a pretty corporate environment. I couldn't just wget stuff from the internet. I need to have an export set with an HTTP proxy. Docker didn't really get that, so Docker pull, stuff like that started failing. So we needed to work around that, and none of the plugins we worked. So we did what every ops guy back in those days did. How do you manage how do you orchestrate your whole Docker infrastructure, and how do you do that these days with Kube? You write shell scripts, and you basically talk to localhost. Setting up Docker was pretty trivial. I mean, Garrett has a really good module there. It's been evolving. But we needed to have stuff like, we wanted to have a local registry to push our images to. I might be running ahead on the slide, but if you have one Jenkins instance and you build something locally, the image is locally, but once you have more slaves and you want to use the same image, you need to have something centrally that you know I'm always going to be building from the same image. So you need an image repository. And this is where we first started getting frustrated with the upstream Docker community, because this parameters, those they still support. But I want to have this host by default and not even go to Docker Hub. And Solomon kind of says, no, I don't want you, because I want to be rich and famous and get a lot of money from you using my publicly hosted repository. Whereas all the corps said, we want to have our internal repository. So he didn't even want to have a config in there that allowed you to directly go to your repository. So we needed to move to the Red Hat fork, which had different features, different documentation. It's a fun ecosystem there. So, empty container, Docker installed, Jenkins installed. Next step. Oh, we want to have an isolated environment. How do I install RVM? Start looking to find a package for RVM. I didn't find a package for RVM. The documentation to actually install RVM is basically curl, pipe, whatever. I think James Turnbull called that a couple of years ago at Config Management Camp in his keynote. He called it having unprotected sex with the internet. So you're like, we're doing this in a container. I'm going to throw it away container anyhow. It's not going to run in production. I'll do this. I'll package up the whole tree. I got RVM installed. I got a container with RVM. I take the next step and say, well, going to install Ruby in there. I'm going to package it. Now I got containers. I got packages with clean Ruby instance. And you start shaving that yak. Let's install dashing. Oh, this is how you install dashing. A lot of dependencies. It basically fills your whole isolated path with all the gems you need, and then you do it again to get like the tree where you actually have the dashboard. So now we have a container with an empty dashboard and some dependencies on Twitter libraries, which you don't want, but you have a container with an empty dashboard, which you can deploy. And initially, you start building up all those Docker layers, and then you learn, I don't always need them. They use disk space, compress them afterwards, and basically lose all the layers, do that in one big Docker file. So now it was time to get the reproducible way of getting the dashboards in there, and all the widgets, and all the code. Yeah, I don't want to have my build go to some random person's gists on GitHub, which he might update or remove tomorrow, or when he's drunk tonight after the party, and like does something wrong on Git. Yeah. That's not how we want to do stuff. So we needed to have a local Git repository with all the mirrors of all the code we were going to use. And we basically created a repository where all of the widgets are in there. And there were not going to be sub-modules. There were not going to be things we could package. So we basically, the only option with this kind of approach was to fork everything locally and start not maintaining them anymore. Because there was, doing that with Gist is pretty much to contribute all those things back and keep those in sync. Specifically because we needed to modify a bunch of those scripts because the config was inside the scripts and things. There's a couple of patches we brought back, but mostly it was examples we used. So we take that, we deploy that from that dashing container, we bundle install with all the dependencies, and we now have a working package. And we could basically take that package, the artifact, upload it to our repositories, deploy it, and be running. And that was basically our minimal viable product. Like, we had a lot of effort done to create a package which was completely isolated, which we could put onto pretty much any rel-based platform and run it. But we forgot something. What did we forget? I know it's early, but it's not the second day. You still should have some brain cells awake. And I know the German audience is typically not really interactive, but I was in Warsaw on Monday, and there I had to ask, are you human beings? And half of the audience didn't raise their hand, so it was kind of weird. So we forgot to test. We didn't test our package. So we figured out, hey, we've got a container that is used to build a package. We have a package. What if we spin up a new container, actually install the package in there, launch it, and start testing if the dashboard still works? And we figured out that we didn't really package everything. There were still files being outside of that package that were deployed by the whole thing. So we spent a lot of time actually figuring out why we failed to isolate a bunch of those packages. Ruby gems. And we didn't see at first because those files were left over from the initial install on the VM where we were doing this. But after a while, we figured out, like, hey, we run this in our pipeline, and then we do a wget to figure out if that container actually serves the page we want, and it works. And then the next step was, okay, now let's use mcollective to actually, on the platforms where we need to have the update, after promote, update dashing gems, update dashing dashboard, on all the nodes with profile dashing, and this is pretty much what we use in that stack. So that was a fully automated way to make sure that we didn't break dashing when people were hacking around. We had now Git repositories where we could rebuild those whole stack from. It was pretty much the goal we wanted to achieve. I already mentioned this. First, we had a single Jenkins instance. Docker pull, Docker push, build. And I had a second node like, I need something to do this. I need to have a repository. I need to have a way to centralize management for my container images so that my builds are going to be identical. And actually, this slide is outdated. Back in August 2016, Pulp was read-only. It was really good for mirrors. I have no clue if they've updated functionality because I stopped looking. There was Nexus and Artifactory, which were really big in the Java ecosystem to be used. There was the upstream Docker registry, which was typically only to be used in a container, which was really not how we wanted to move forward because we were learning and we were trying to understand how containers worked. And then the first thing you don't want to do is actually put a critical part of the ecosystem inside the technology you're trying to understand, because if it breaks, you have two problems to solve. But luckily, they had also the new Docker distribution there, which had rel packages which we could deploy, and we installed them. Eventually, we moved away from Docker distribution. We are now running mostly Nexus for Docker images because it's typically in an environment where you also use Nexus to mirror Ruby gems, where you also use Nexus to mirror Node.js, and basically, well, the rest of the internet. We had our fair share of Docker versus Docker. Well, the Red Hat community versus the Docker community. Well, is there such a thing as a Docker community? I mean, do they listen to what your community says? Or do they just blindly start hacking on stuff and don't understand their feedback loop? There was a bunch of changes there. And then I haven't even talked about stability issues, because there were stability issues. The number of file system issues we had, the number of, hey, why does this disk suddenly full? There is a sparse loopback file, which nobody mentioned. Oh, it's full. Let's move this to device mapper. This is a tin provisioned LVM backend. It's growing like hell. I need to clean this up every 5 minutes. Not every day, like the documentation says. And yes, it was about 1 terabyte. So it was a pretty big one. And then still containers not starting, containers crashing, containers being irresponsible and irresponsive. It learned us that at that moment, the technology was absolutely not ready to be used in production. Things have evolved. It's getting slowly better. But back then, nope. I think we're slowly getting to a point where you can start using it. I mean, the number of times we kill Jenkins slaves today is, I think in April we were still on a farm with about 20 Jenkins nodes, Jenkins slaves, all running Docker. We were pretty much killing the nodes at a rate of 2-3 per week. And killing the nodes basically is the cattle versus cow effect. We stopped caring about debugging it and fixing it. We just kill the node, reprovision another one. But it's evolving and there's other container solutions popping up. So we solved these kind of problems. We had a build environment, no complex build, no writing spec files. We have internal repositories, kind of a Jenkins and Docker integrated. And we could do this for different other patterns. We do this for Python, we do this for Puppet, we do this for currently Python, Java, PHP, Node.js, and a lot of other stacks. And for our Puppet pipelines, for example, we now test our code different Puppet versions. We do the same for PHP. We have an isolated environment, we package the software, and then we actually run the tests on both PHP 5, the latest, and 7, and whatever the developers want. Our Puppet code, our migration strategy for our Puppet infrastructure is like the majority of people are still on 3.7, 3.8. We run our tests on 4, we run our tests on 5, and we start working towards getting them green, but we don't use them in production yet. And we do that for a lot of things. But then we end up to the next problem. How do you build a pipeline? How do you scale a pipeline? That's the second part of the talk. We're doing this using pipeline as code. We're doing this using the Jenkins DSL. And it has given us a lot of flexibility. What we did is we set up a development Jenkins. That's where people are allowed to just hack around. They can create manual C jobs. They can create manual jobs, but that's nowhere where code is going to run. We use the Jenkins DSL plugin because it's, for us, still the most flexible one around. We had a couple of iterations before. We looked at the Jenkins Job Builder from the OpenStack community. That was a really good start, but it was really limited to functionality. You couldn't really, well, you had to write a lot of the Python code yourself to support a bunch of the new models. The OpenStack community kind of abandoned the ecosystem themselves. Before that, I think Julien gave a talk about that like 2 years ago at OSDC, or 3 years ago. We actually even once templated the XML from the Jenkins using Puppet ERBs. And then we started evaluating a number of new popping up. There's the pipeline plugin, where you drop in a Jenkins file in the repository, and it's Groovy, and you just let the pipeline being generated from that. But we felt that that tool was really too limited for us. It still is. One of the first problems we had with it was the limitations it had. When you started using it with multiple stages, and you had a pause in a pipeline somewhere, that pause actually was a running resource. So if you had a node which could execute 8 jobs, and you had 7 pipelines in wait, the 8th pipeline in wait was going to basically block your Jenkins, even though it was doing nothing. I mean, they fixed that bug then, but that was like really not the kind of things we wanted to use. The other thing with the pipeline plugin, it's really container focused, and it takes the idea that you always have a straight pipeline. You go from dev to acceptance to production. And a lot of the use cases we have is, I go from dev to acceptance, and then sadly, I live in Europe. So I have my own software as a service platform where I go, and that's one straight line. But I also have 4 on-prem customers who want exactly the same code base, but they don't believe in continuous delivery yet. They want it on-prem, and I need to take a side way, and I'm going to do that at a lower frequency, or I need that when they want. So I have pretty much a fork structure where my pipeline goes straight, and then the other ones are lagging behind. I've got another talk about building your software as a service stack on-prem. The short summary for that is don't. Except if you can convince your customer to pay 10 times the actual charge, because then you might actually be doing things. So we ended up using the JobDSL plugin, which is Groovy. And I'll come back with some code examples later. We version all the jobs. We put them in Git. And this is basically a pipeline, a C job that generates the jobs you need. Jenkins sees a change in Git, like any other package, like any other piece of software, triggers that job. That is a C job. That C job generates all these little jobs. In a dashing project, in a subfolder, it actually creates dashboard deployed, dashboard test, dashboard build, deploy to production, and all of those things. And we can do it on different Jenkins environments, and we can actually say, hey, this now is a stable pipeline. I'm going to promote this pipeline, and I'm going to use this one in production. And then people can still work on the pipeline, but it's not going to break the production build, which was something we were struggling with typically. Like, you got a Jenkins, we want to change a little part, somebody goes to the UI, changes it, now the pipeline is broken. Not because of the software, but because the pipeline has changed. We've isolated actually the building of the pipelines from using the pipelines. So this is what a typical DSL project looks like. I define a project, create a folder, create a bunch of jobs, get a build pipeline view, then create this. And I fill that up. There's typically a bunch of parts in there, like job rotation, source control, when do I want to build it, add a label if I want to have it on a specific machine with specific restrictions. The actual hard work, like Docker run, Docker build, typically in shell files, they're versioned, and how we publish them. Publish a build, archive the artifact, all of these kind of things. So this is an example of a really small job. I keep 5 builds. I keep 5 builds there. This is my source control. I pull every 5 minutes. Needs to run on a Docker box. This is the script. And then I publish the build. I clone the workspace to the next one, and I pass on that workspace to the job that does the test, if successful. And I pass on a couple of parameters. So this is pretty easy code, right? This is if you prefer this compared to digging into an XML file, or actually going to a user interface and clicking around. I don't ever want to see the Jenkins user interface used anymore. I mean, the frustration I had with Jenkins was its user interface. By moving to pipeline as code, I basically made it headless. And now it really does the work I want. I see the pipeline output, but it's reporting. It's not actually configuring stuff. So what we solved was a bunch of those things. Like no more, I mean, in the Drupal ecosystem, we call those people the dirty clickers. No more dirty clicking. Actually writing code. Problems we had before was that we have one job that was being reused with different parameters. Like if you have one job, package this and it takes 10 different inputs and 10 different outputs because it's fully parameterized, which was back then a good idea. You run that job 10 times and the 11th run basically overrides the first one and you don't have the history anymore. And the developers were like, but there's so much stuff going on and it's 5 minutes and all my builds are gone because there's 10 other jobs. And now we have jobs which are dedicated for one project, but the content of the job was identical and they're centrally managed. And by using containers, we solved a lot of these topics. Like we can now have multiple versions. We can have really reproducible environments. We don't have to manage the dependencies of all those different builds on the file system. Like ages ago, we had 5 different Jenkins slaves, one for PHP 5, one for PHP, one for Python this, and we used the nodes tags to actually spin up the tests on the right versions. Now we just do that in a container. And we learned a lot on how to manage and how not to manage containers. And that was for a lot of people actually the best part of that project. Because we figured out that at that point, containers were, well, Docker was not ready for prime time. Containers were a different story because we were using LXC already for a couple of other topics. So what initially was like, we need to make dashing reproducible and we need to be able to build a dashboard that we know that we can deploy all the time and where we know that developers won't break it, actually became a real experience on teaching operations people how to build pipelines with a tool they knew and give them experience on how to manage a couple of those things. So that basically was 3 months well spent over summer 2 years ago. Any questions? Are you all awake?
If you have some questions, handing the microphone to you.
In the back.
All right.
Hi. So did I understand correctly, you are using pipeline and Docker, but you are not using any of the plugins, but using shell code?
Yeah. So you have to put this experience somewhere about 18 to 24 months ago. Like I said, most of the plugins for Jenkins at that time, well, they didn't work. First example was they expected Jenkins to run as root because they were talking to the Docker sockets. They didn't have support to talk to Docker over localhost. They didn't support the fact that I needed to set an environment variable to get my Docker pull images pulled in. So the only way back then for us was to use a shell script and actually do that. I mean, things have evolved. But I think most of the people at that time frame were like, how do we run anything with Docker? We write a shell script to spin it up. Kind of the same today when how do you tell Jenkins to deploy on Cube? Well, you write a shell script to import your stuff. It's kind of the same. I wouldn't do it today. Today it would be different. But back then that was pretty much the only solution we had.
Okay, thank you.
Any other questions in the audience?
Are there more things that you would do differently to this approach? Because it looks like how you do it initially, but things have evolved a bit.
I think one of the things I said, we used to have different layers on containers, like we built one with a CentOS image, then we built one with Ruby, then we built one with RVM, then we built one with dashing, and then one with the actual application. Right now it's just one small Docker file, and we build it from there. So that's kind of the things we learned. What we didn't have then was, we were still pulling in Ruby gems from rubygems.org, which was one of the things I wanted to fix because I knew that we had nightly, well, we had another pipeline which was basically packaging Ruby gems for us of gems that we were depending on in other parts. And we frequently saw them failing, typically like the Sunday nights when rubygems.org was having issues, but So things we added in the meanwhile was having Nexus to have our own local Ruby gem repository, and we built from that. We still haven't figured out how to get RVM solved, because that's still having unprotected sex with the internet. We've been experimenting with not having a Jenkins slave and Docker on there, but trying to let an orchestration framework basically say, hey, build this container, run it, build it somewhere, and I don't care how. But we're still struggling between, you need to manage something. You need to manage either a swarm of Jenkins slaves or a cluster of Docker containers. And it's like, which one is going to be the most healthy one? People come up and say, yeah, but if you're in resource needs, you can spin up more Docker containers. It's like, yeah, but I still need to manage the VMs on which the containers run, so I still need to provision a VM with the container. Except, of course, if you are on Google Compute or whatever and just you don't care about the containers, which in this corporate environment and in a lot of other corporate environments where I have to work, it's not an option. So those are things we're evaluating. This is basically a pattern we abandoned. We now don't write this specific code anymore. We don't write the specific jobs anymore. We build a library where now every job is using our library to package thing. And this used to be spaghetti. This used to be the typical thing which happens when you start writing code. Like, I need to write a class that does this. And then the guy next to you figures out, I need to write a class that does exactly that. And at first you're experimenting, and if you start designing this up front, you're going to over-design. And we took the approach where I said, let's do it hard-coded the first time, and then figure out which patterns we actually have. So now we basically have a library. We have a library that kind of does all of these. And then the difference, so there's no dashing anymore. There's no specific dashing jobs we write anymore. But there are build jobs, there are upload jobs, there are deploy jobs. They're there. And then the specific dashing one is like the package job, which only does that. But all the other ones are generic. So that stuff we improved. There are other things which we would do different. Maybe I'll come up with some later, but that's a couple of the things we improved in between. And well, if I would have to start from scratch today, I probably would not use Docker, but CRIO, just to play with it. More questions?
All right, if not, then we end the talk.
Yep.
Thank you very much. Please give a great applause for the great speaker.